Yes. Good afternoon, students. Welcome to the Real Analysis live lectures. Uh, in yesterday's lecture, we have seen what is different definitions about sequence, bounded sequence, monotone sequence, then convergent sequence, and some of their examples. Okay, so now today I given some examples also for homework to check convergence. Whether you did it?
Yes, ma'am.
Any problem? Everybody got it? Everybody did that two examples. I told you to check 1 plus 1 by n tends to 1 and 1 upon n square tends to 0. That two examples I told you to prove. So I hope everybody might have did it without any problem, because Archimedean property, same thing we have to use. Okay, now today we'll start a theorem. Every convergent sequence in R is bounded. So we have to prove every convergent sequence of real numbers is bounded. So what is meant by a bounded sequence? What is bounded sequence? Xn is said to be bounded if we can find a real number m such that mod of xn is less than equal to m. Right?
Yes.
Yeah, so, and what is mean by convergent sequence? Xn is said to be convergent sequence converging to x belongs to R if for given epsilon greater than 0 there exists a natural number n0 satisfying the condition
Mod of xn minus x is less than
epsilon for all n greater than equal to n0. Yes. So we'll start a proof. What is given? Let xn be a convergent sequence of real numbers converging to x belongs to R. That is xn convergent to x. Let xn converges to x. So this is given. We have started with an arbitrary convergent sequence, say xn, and say its limit is xn converges to x. And what is my claim now? I want to show this xn is bounded. I want to prove this xn is bounded. So I want to find a real number such that mod of xn is less than equal to m for all n. So how can I prove this? I am having this one, convergent. Here, let epsilon is equal to 1, or for epsilon is equal to 1. Since xn converges to x, for epsilon is equal to 1 also there exists some natural number which satisfying the condition mod of xn minus x is less than 1, right? So in particular for epsilon is equal to 1 also there exists some natural number. So for epsilon is equal to 1, there exists n0 natural number such that mod of xn minus x is less than 1 for all n greater than equal to n0 by using the definition of convergence. Is it okay? So what? Yes. So what can I say about mod of xn? This implies, what can I say about mod of xn?
1 plus x
Is less than equal to 1 plus mod x for all n greater than equal to n0, right? Yes. So mod of xn is less than equal to 1 plus mod x for all n greater than equal to n0. So suppose I am having x1, x2, x3. Say this is xn for n0 and xn n0, say then next n0 plus 1 and so on. So mod of xn is less than equal to 1 plus mod x for all n greater than equal to n0. So how can I prove one mod of xn is less than equal to m? How I got this? Can you see this? How I have written this?
Ma'am, can you repeat the question, please?
Yeah, I want to show it is bounded. So when I can say it is bounded, let me write here. That is, what is my claim? Xn is, I want to show xn is bounded. That is, I want to show there exists m belongs to R such that mod of xn is less than equal to m for all n. That I want to show. So how can I show that one? By using xn converges to x. I am having, since it is convergent for every epsilon, why there is a noise?